This is lesson 4.3, graphing linear functions. Graphing these functions is actually pretty straightforward because you only need two pieces of information. If you are given the slope and 1 point on the line, these are the steps you follow to graph that linear function. The first step is just plot whatever that point is, the xy point that you're given, and then use the slope to find another point that would be on this line. So you have whatever point that you were given, and then just count up your rise and over your run until you get to another point. And then all you have to do is connect the lines. I would recommend finding 3 points before you connect, not just 2, to ensure that you haven't made a mistake. If once you've plotted your points, you go to connect them and it's not in a perfectly straight line, then you've definitely done something wrong because these are supposed to be straight linear functions. So you should go back and check your work. These examples show what I mean. We want to graph the line that passes through the given point and has the given slope. So example 1a, we have the point that goes through the point 1, 2 and has a slope of 1/2. So the first step is to plot 1, 2, which would be right here. Over 1, up 2, I plot my point. To find another point, I use my rise over run to count. So from here, I went up 1 and to the right 2, and I plotted another point. And then I repeated that again, up 1 over 2 to get a third point here. Just for this question, I also discovered 2 points down here by going the other direction. Of course, if like going from this way, I went up 1 over 2, but going this way, I have to switch. So I'm going down 1 and to the left 2. So it's like my slope is -1 over -2, which of course is the same thing as 1 over 2. We're just going in the other direction. So from here, I went down 1 over 2 to get my new point, and then down 1 over 2 again. You don't need to have 5 points. 3 is a good place to be. You'll just connect it with the straight edge, and you're finished. You can also check that you've done this correctly because we know that the slope is positive here, and this is rising to the right, so it looks like we're on the right track. For this example, we have the point -3, 1, and the slope is -2/3. So first step is plot the point over -3, up 1, so that's the point right here, and then we had to find at least 2 before we can connect them. The slope is -2, 3, so from here, I can go down 2, and then to the right 3, which gets me my new point here. I could have also gone in the other direction, this way, and I could have gone up 2 and to the left 3, and then that gets me my point there. So you obviously would know that you made a mistake. Let's say I had these 2 points, and then I went up 2 and over 3 and tried to plot a point here. Obviously, that doesn't make sense because it'll have some kind of weird triangle shape, and it wouldn't be a straight line. So that's an indication that you would have been doing something wrong. It has to connect in a straight line. That's why it's, again, helpful to do at least 3 points to ensure you haven't made a mistake. Then connect them with a straight edge. On the test, you need to have a ruler or some straight edge. You can't just freehand and try to make it a straight line. When you're drawing your lines, make sure that you extend it to the full edge of the graph. Don't just do the 3 points that you covered. Extend it to the end and put arrows on the end. That's critical because this line goes on forever. This domain and range is going to be all real numbers. It's not just between the couple points that you found. You extend the pattern forever. So if you try to do the same thing and your line looked like this instead, and you stopped it, it looked like something like this. You had your 3 points and that was all you did, and you didn't extend it with arrows on the end, you would not get full marks for that because that's a different equation. That has a different domain and range. All these linear functions have all real numbers as the domain and the range. Some other new vocabulary is the X-intercept and the Y-intercept. Intercepts are just where the function crosses the axis. So the X-intercept is where the function crosses the X-axis, or the horizontal one, and the Y-intercept is where the function crosses the Y-axis, or the vertical one. Intercepts are helpful because they're very specific points on the graph. So for example, the X-intercept, let's say the X-intercept is 2, then the point is going to be 2, 0. You always know that the Y value in the X-intercept point is going to be 0, because if you're crossing the X-axis, like let's say right here, the X-axis is at Y = 0. So the point is always whatever the X-intercept is, 0. Whereas for the Y-intercept, it's switched. The X value is always 0, because if you're on the Y-axis, the X value is 0. And then it'd be whatever the Y value is for the Y-intercept. Some examples, determine the x-intercept and y-intercept of the linear functions below. Pretty straightforward. X-intercept is wherever it crosses the x-axis. So that's this point here, which is the point -3, 0. The y-axis, wherever the y-intercept is wherever it crosses the y-axis, which is right here. So that'd be at the point over 0, up 1. Similar idea for this example B. There's the y-intercept, there's the x-intercept. We write the coordinates of whatever those points are. Another example, determine the slope of a line that has an x-intercept of 2 and a y-intercept of -3. So you don't actually have to be given the entire coordinate of the point. If you know the x-intercept is 2, it's crossing the x-axis at x equals 2, which means it has to be the point 2, 0, because it's an intercept. So we have our 2 points, 2, 0, and 0, -3, and we can just throw this into our slope formula, y2 minus y1 over x2 minus x1. So -3 minus 0 over 0 minus 2 makes our super easy calculations. That's another thing that's nice about intercepts because there's so many zeros in it. This just leaves us with -3 over -2, which simplifies to 3 over 2. So if you're determining the slope of a line and you're given the intercepts instead of just 2 other random points, it's usually a lot quicker to calculate because the zeros make for easy calculations. And then these 2 examples, draw a line with a slope of -1/2 and an x-intercept of 3. So this is similar to earlier questions where you're given a slope and a point. It's just the point you're given is the x-intercept, but you do everything the same way. It has an x-intercept of 3, you go to the x-axis and you put your intercept right there. Use your slope to find the next point. So we would go down 1 over 2, or we could go up 1 to the left 2. Get a couple points in there, connect it with a straight line that extends through the graph and has arrows on the end. This example here, draw a line with an x-intercept 2 and a y-intercept -3. So in this case, we don't actually have the slope, so we could find it, but instead we can just plot these 2 points and connect them. Also makes it very easy. So x-intercept of 2 is right here, y-intercept of -3 is right here. And yes, we only have 2 points, but we know we've plotted these correctly, so we can connect them with a straight line with arrows on the end. And this is the last example here. Draw a line with an x-intercept of 4 and no y-intercept. What is the slope? So this is one of our special cases. If there's no y-intercept, it means that it has to be a vertical line. And of course, if it has an x-intercept of 4, it's just going to go straight up. There's no situation where it's ever going to cross the y-axis. So this has to be a vertical line, which has an undefined slope. This also works the other way with horizontal lines. Most horizontal lines do not have an x-intercept. They continue left and right forever, and if they're not already crossing the x-intercept, they're never going to. So this is how we can graph linear functions given either the slope, points, the intercepts, or other information.